Assalamu alaikum wa rahmatullahi wa barakatuh. Today I'm going to talk about the quadratic function. In the previous lesson, we studied the linear function and the graphical representation of the linear function. But today we will talk about the quadratic function and its graphical representation. What is the quadratic function? It is a polynomial function of second degree. So it is a function from the set of real numbers to the set of real numbers. And it can be written in the form f of x equals ax power 2 plus bx plus c, where the coefficients a, b, and c belongs to the set of real numbers, but the coefficient of x power 2 must be any real number except 0. A doesn't equal 0. Examples. F of x equals 2x power 2 plus 7x plus 3. This function is of second degree because the highest power of the variable x is 2. So this is called the quadratic function. F of x equals x power 2 plus 4x. This function is of second degree because the highest power of the variable x is 2. That means it is of second degree, and it is called quadratic function. Also, this function is of second degree because the highest power of the variable x is 2, so it is also quadratic function. Now we will take the graphical representation of the quadratic function. We've studied before that the constant function is represented by straight line. And then we studied the linear function, and it is also represented by straight line. But now we will take that the quadratic function is not represented by straight line. It's represented by a curve. Example. Graph the function f of x equals x power 2, taking x belongs to the closed interval, -2 and 2. And then we need to find the point of the vertex and the equation of the line of symmetry and the maximum or minimum value of the function. We said before, if we need to find the image of any element belong to the domain, we need to use the function rule. So at the first, we need to make a table which contains the elements of the domain or the elements which belong to the closed interval, -2 and 2. The first element is -2 and the last element in the interval is 2. And then we need to substitute by these values in the function rule to find their images here. The first element in the interval -2, we can find its image by using the function rule. If we replace the letter x here by the number -2, it's going to be -2 power 2 equals +4. Also, if we need to find the image of the element -1, we can replace the letter x in the function rule by the number -1. It's going to be -1 power 2 equals +1. And if we need to find the image of the element 0, we can replace the letter x in the function rule by the number 0. It's going to be also 0. And if we need to find the image of 1, we can change the letter x here with the number 1. It's going to be 1 power 2 equals 1. Also, the image of 2, 2 power 2 equals +4. Now we can plot these ordered pairs in the two coordinates, x-axis and y-axis. The first ordered pair is -2 and 4, and its location is here, -2 and +4 here, is located here. And the second ordered pair, -1 and 1, it's located -1 and 1 here. Its first projection, -1, and second projection, +1. And the ordered pair 0 and 0 is located in the center here. It is called origin point. And the fourth ordered pair 1 and 1 is located here. Its first projection 1 and second projection 1. And the last ordered pair 2 and 4 is located here, 2 and 4 here. And then we can join these points to make a curve like that. Now we need to find the vertex of the curve, the vertex point of the curve. We can notice here, this is the vertex of the curve, and its coordinates 0 and 0. And it is also called origin point. So the origin point is also the vertex point of the curve. Then we need to find the equation of the line of symmetry. What is the line of symmetry? It is this line. It is the line which divides the curve into two equal halves, or two equal parts. So this line is called line of symmetry, and it cuts x-axis at the point 0 at the element 0. That means its equation must be x equals 0, because it cuts x-axis at the element 0. So the equation of the line of symmetry is x equals 0. The minimum value of the function. We can find the minimum value of the function on the graph. It's here. This is the minimum value of the function. We can take it from y-axis. It is 0. Here is the minimum value in y-axis. It's 0. Another example. Graph the function f of x equals negative x power 2, taking x belongs to the closed interval negative 2 and 2. And then we need to find the point of the vertex, the equation of the line of symmetry, and then the maximum or minimum value of the function. So at the first, we need to make a table which contains the elements of the domain and the elements of the codomain. We can put the elements of the domain in this interval by using this interval. This interval, its start, the negative 2 is the first element in the interval. I will start from negative 2, and the last element in the interval is 2. Here I will write 2, and this is the elements between negative 2 and 2. We need to find the images of these elements by using the function rule negative x power 2. So to find the element, to find the image of the element negative 2, we need to substitute by the value of x equals negative 2 in the function rule, or replace the letter x by the number negative 2 here. The result is going to be negative 4. And then if we need to find the image of the element negative 1, we have to replace the letter x here by the number negative 1. The result is going to be negative 1. And if we replace the letter x by the number 0, the image is going to be 0. And if we replace the letter x by the number 1, the final result is going to be negative 1. And if we replace the letter x by the element 2, it's going to be negative 2 power 2 equals negative 4. Now we can plot these ordered pairs on the two coordinates x-axis and y-axis. The first ordered pair, negative 2 and negative 4, is located here, negative 2 and negative 4 here. And the second ordered pair, negative 1 and negative 1, is located here. And the point, or the ordered pair 0 and 0, is located here in the center. It is the origin point. And the ordered pair 1 and negative 1, it's located here. And the last ordered pair 2 and negative 4 is located here. Now we can join these points to make a curve like that. From the graph, we can deduce the point of the vertex of the curve. The vertex of the curve is located here. It is the origin point whose coordinates 0 and 0. And the equation of the line of symmetry. As we said before, that the line of symmetry is the line which divides the curve into two equal parts. So this is the line of symmetry, and it cuts the x-axis at the element 0. That means the equation of the line of symmetry is x equals 0 because it cuts x-axis at the element 0. The maximum value of the function. We can find the maximum value of the function by using the graph. This is the maximum value of the function. We can take it from y-axis. The elements which represent the maximum value on y-axis is 0. So the maximum value of the function is 0. Graph the function f of x equals x power 2 minus 2x minus 3, taking x belongs to the closed interval -2 and 4. And then we need to find the point of the vertex of the curve, the equation of the line of symmetry, and then the maximum or minimum value of the function. So at the first, we need to make a table which contains the elements of the domain or the interval -2, which start from -2 till to reach 4. -2 till to reach 4. And then we need to use these elements to find its images here, their images here. We can use the function rule to find the images of these elements. So at the first, we need to find the image of the element -2. To find the image of -2 by using the function rule, we have to replace the letter x here and here by the number -2, and the final result is going to be 5. So the image of -2 is 5. And the image of -1, we can find it by using the function rule. We have to change the letter x here and here by the number with the number -1. And the final result, if we calculate it, it's going to be 0. So the image of -1 is 0. And to find the image of 0, we can replace the letter x in the function rule by the number 0, and it's going to be -3. The image of 0 is -3. And if we replace the letter x by the number 1 in the function rule, its image is going to be -4. And if we replace the letter x in the function rule by the number 2, its image is going to be -3. And the image of the element 3 is 0, and the image of the element 4 is going to be 5. Now we can plot these ordered pairs on the two coordinates x-axis and y-axis. The first ordered pair, -2 and 5, is located here. -2 and 5 is up here. And the ordered pair, -1 and 0, is located here. And ordered pair 0 and -3, 0 and -3 is located here. And the ordered pair 1 and -4, 1 and -4 is located here. And the ordered pair 2 and -3, 2 and -3 is located here. And the ordered pair 2 and -3 and 0 is located here. And the ordered pair 4 and 5 is located here. Now we can join these points or these ordered pairs to make a curve. And now we can find the point of the vertex of the curve. This is the vertex of the curve. This point represents the vertex of the curve, and its coordinates 1 in the first projection and -4 in the second projection. So the coordinates of the vertex point of the curve is 1 and -4, because the first projection is 1 and the second projection opposite to -4 in y-axis. And the equation of the line of symmetry. As we said before, the line of symmetry is the line which divides the curve into two equal parts. So this is the line of symmetry, and it cuts x-axis at the element 1. That means the equation of the line of symmetry is x equals 1. and the minimum value of the function. This is the minimum value of the function. And as we said before, we can take it from y-axis. The element which represent the minimum value of the function, we can take it from y-axis. So the element -4 is the minimum value of the function. Graph the function f of x equals -x power 2 plus 3x plus 2, taking x belongs to the closed interval -1 and 4. The point of the vertex, we need to find it, and the equation of the line of symmetry, and the maximum or minimum value of the function. At the first, we need to make a table which contains the elements of the domain and the elements of the codomain. The elements of the domain is the same elements in the interval, which start from -1 and till to reach to 4. The first element, -1, we can find its image by using this function rule. If we replace the letter x by the number -1, its image is going to be -2. And the image of the element 0 is 2, the elements of 1 is 4, the elements of 2 is 4, the image of the element 3 is 2, the image of 4 is -2. Now we can plot these points on the two coordinates x-axis and y-axis. The first point, -1 and -2, it located here, -1 and -2. And the point 0 and 2, 0 and 2 is located here, and the point 1 and 4 is located here, and the point 2 and 4, 2 and 4 is located here. Here, this is the point with first projection 2 and second projection 4, and the point 3 and 2, 3 and 2 is located here, and the point 4 and -1 is located here. 4 and -2, 4 and -2 is located here. It's first projection 4 and second projection -2. Now we need to find the vertex point of the curve. This point represents the vertex point of the curve. Its first projection in the middle here, in the middle of the element 1 and the element 2. So it represents the element 1.5. So the first projection of the vertex point is 1.5. And the second projection is here. It represents the element 4 and 25, 4 and quarter in y-axis, on y-axis here. So the vertex point, its coordinates, the first projection is 1.5, and the second projection 4 and 4.25, or 4 and quarter. Now we need to find the equation of the line of symmetry. As we said before, the line of symmetry, it is the line, this line, it is the line which divides the curve into two equal parts. So this is the line of symmetry. And this line cuts x-axis at the element 1.5. That means the equation of the line of symmetry is x equals 1.5, or 1.5. The maximum value of the function. This is represent the maximum value of the function. And as we said before, we can take it from the y-axis here. This element represent the maximum value of the function, and it equals 4.25. So this is the maximum value of the function. From here, we can deduce that we can take the equation of the line of symmetry from the vertex point. We can take it from the first projection of the vertex point. So this is the line of symmetry, or the equation of the line of symmetry. And then we can find the maximum or minimum value from the second projection of the vertex point, 4.25. So the maximum value is 4.25. In general, we can use the vertex point to find the equation of the line of symmetry and the maximum or minimum value. The first projection in the vertex point represents the equation of the line of symmetry, and the second projection of the vertex point represents the maximum or minimum value of the function. Remarks. From the previous, we can deduce that the quadratic function f of x equals ax power 2 plus bx plus c. If a more than 0, or if the coefficient of x power 2 positive more than 0, then the curve is open upwards, and the function has a minimum value equals f of negative b over 2a. But if a less than 0, or the coefficient of x power 2 negative, that means the curve is open downwards, and the function has a maximum value equals f of negative b over 2a. And the vertex point, we can find it without using the graph, but using this rule. The first projection, negative b over 2a, and the second projection, f of negative b over 2a. And as we said before, in general, we can take the minimum value of the function from the vertex point. It represents the second projection. This is the second projection of the vertex point of the curve. It represents the maximum or minimum value. And also we can take the equation of the line or axis of symmetry from the vertex point. It represents the first projection in the vertex point, negative b over 2a. X equals negative b over 2a. Let's answer some exercises. If the point 3 and 2 is the vertex of the curve of the quadratic function, then the equation of the line of symmetry is what? As we said before, we can take the equation of the line of symmetry from the vertex point. It represents the second projection of the vertex point. And the second projection of the vertex point here is 2. That means the equation of the line of symmetry is x equals 2. Sorry, we can take the equation of the line of symmetry from the first projection in the vertex point. It represents the first projection of the vertex point. That means the equation of the line of symmetry is x equals 3, because the first projection is 3. It's not 2. Sorry. Number 2, the equation of the axis of symmetry of the function f of x equals x power 2. According to the rule, we can find the equation of the line of symmetry, x equals negative b over 2a. But here we don't have the coefficient b, which represents the coefficient of the variable x. It's not here. That means b equals 0. So if we replace the letter b in the function rule, or in the rule, negative b over 2a, the final result is going to be 0. That means the equation of the axis of symmetry is x equals 0. Number 3, the point of the vertex of the curve of the function. According to the rule of the point of the vertex curve, the first projection, negative b over 2a, and the second projection, its image, the image of negative b over 2a. If we substitute by the values or the coefficients, a equal 2 and b equals negative 4, in the rule of the vertex point, the first projection, negative b over 2a, and the second projection, its image. The final result is going to be 1 and 3. Number 4, if the curve of the function f such that f of x equals x power 2 plus c passes through the point 0 and 2, then c equals what? Since the ordered pair or the point 0 and 2 belongs to the set of the function, that means the image of the element 0 is 2. F of 0 equals 2. So if you replace the letter x in the function rule by the number 0, the final result is going to be 2. Let's do it. If you replace the letter x here by the number 0, the result is going to be 0. So we can ignore this term. That means C is going to be equal to, C equals 2. Number 5, if f of x equals a plus x power 2 and the other function h of x equals c, are two polynomial functions where 3f of 2 plus 3h of x equals 6, we need to find the numerical value of the expression 2f of 0 plus 2h of 7, where a and c are constants. At the first, we need to use this equation, 3f of 2 plus 3h of x equals c equals 6, to find the values of the unknowns. At the first, we need to find the value of the element 2 by using the function f. So we have to replace the letter x in the function f here by the number 2. F of 2 is going to be a plus 2 power 2, or a plus 4, because 2 power 2 equals 4. That means 3 is going to be multiplied by the sum of a and 4, plus 3 times h of x equals what? We have to replace the letter x in the function h by the number c. H of x represents a constant function, and we said before that the constant function, the set of all images in the constant function equal the set which contains this constant. That means if we replace, or if we need to find the image of any real number, the result is going to be constant, c. That means h of x equals c equals 6. Now we can find or solve this equation. At the first, we need to multiply 3 inside the two brackets. 3 times a equals 3a, 3 times 4 equals 12, plus 3c. We can move 12 to the other side with negative sign. It's going to be 6 minus 12. And then we can find, or we can take 3 as a common factor from the left-hand side. It's going to be 3 bracket a plus c, and the other side 6 minus 12 equals a negative 6. We can divide each side of the equation by 3, so it's going to be a plus c equals a negative 2. And now we need to find the value of the expression 2f of 0 plus 2h of 7. F of 0 means the image of the element 0 in the function f. So we have to replace the letter x in the function f here by the number 0. It's going to be a plus 0 power 2, or a. We can ignore 0 power 2. So 2f of 0 is going to be 2a. And 2h of 7. H of 7 means the image of the element 7. And we know that this function, or h of x equals c, represent the constant function, and the image of each element here is the same constant c. That means h of 7 equals c. So we write 2c. Now we can write 2a plus 2c, and then we can take 2 as a common factor. It's going to be 2 multiplied by the sum of a plus c. We can replace a plus c, this expression, we can replace it by the number negative 2, because A plus C equivalent to -2. If we replace A plus C by the number -2, it's going to be 2 times -2 equals -4. So -4 represent the value. It is the value of the expression 2f of 0 plus 2h of 7. The opposite figure represents the curve of the function f, where f of x equals m minus x power 2. And OA, this equals 4 units. We need to find the value of m and the coordinates of b and c. And then the area of the triangle whose vertices a and b and c. What should I do to find the value of the unknown m? We can use this point, the point A, because the point A belongs to the curve. Actually, it is the vertex point of the curve. We can use it to find the value of the unknown m. Since 0 and A belongs to the curve, that means the image of the element 0 is 4, or f of 0 equals 4. So if you replace the letter x in the function rule here by the number 0, the result is going to be 4. If we replace the letter x here by the number 0, it's going to be m minus 0 equals 4. That means m equals 4. Now we can substitute by the value of m here, or replace the letter m here in the function by the number 4. So the function is going to be f of x equals 4 minus x power 2, because m equals 4. And to find the intersection point with x-axis, we said before that we need to put y equals 0, or f of x equals 0. So if we put y equals 0 or f of x equals 0, that means 4 minus x power 2 equals 0. Now we have a function, now we have an equation of second degree in one variable. We can solve it easily. If we replace, or if we move 4 to the other side, or negative x power 2 to the other side with positive sign, it's going to be x power 2 equals 4. If we take the square root to the two sides of the equation, x is going to be positive or negative 2. That means the coordinates of b is 2 and 0, and the coordinates of c is going to be negative 2 and 0. And now we can find this distance is going to be 2 units, and this distance is going to be 2 units, because the coordinates of b is 2 and 0, and the coordinates of c is negative 2 and 0. And now we can find the area of that triangle whose vertices a and b and c. We know that the area of any triangle equals half times base times height. And the height is 4 units. And the base here is 2 plus 2. The full distance here is 4. So the base is 4. That means the area is going to be half times 4 times 4 equals 8 square unit. And this is the area of this triangle, the triangle whose vertices A and B and C. Now the time is over. Thanks, guys. I hope you study hard. Wassalamu alaikum wa rahmatullahi wa barakatuh.